to find a z-score and make comparisons. So you're going to do the same thing as you did yesterday and the lesson before that, but you just have one small little thing to add on to it. Here's an example. The list of numbers here will be 4, 5, 9, and 2. So we have to find the standard deviation first. Before that, you have to find the mean. So add them up to get 4, 9, 18, and 20. So the mean is 20 divided by 4. 4 is the number of numbers in the list, and that means the average is 5. Now you can find the standard deviation. So each number in the list minus 5, and then square the result. 5 minus 5, square it. 9 minus 5, square. And 2 minus 5, square. Divide everything by 4, and then a square root. So when we go back and look at this, we'll have a negative 1 squared is 1. And then 5 minus 5 is 0. 0 squared is 0. 9 minus 5 is 4. Squared is 16. And 2 minus 5 is negative 3. Squared is 9. Add those up. 1 and 0 is 1, plus 16 is 17, plus 9 is 26. So you're looking for the square root of 26 over 4. And that comes back to be, rounded to the tenths place, 2.5. The question for this whole problem is going to be that you have to compare one item from this list from an item from another list. The item that you're going to have to compare in this list is going to be 5. We're going to choose another item from the next list that we do and then compare the two of them. But for right now, you have to remember that 5 is the item you're going to compare, the mean is 5, and the standard deviation is 2.5. List number 2 has the following numbers: 7, 2, 6, 10, and 5. And just like the last list, you have to find the mean first before you do the standard deviation. So we'll add those up to get 7, 9, 15, 25, and 30. And we have 5 numbers in the list. 30 divided by 5 is 6. In this list, the number we're going to compare is also 5. We're going to choose 5 from that list as well. But before we do any comparisons, we have to find the standard deviation. So 7 minus the mean, square it. 6 minus the mean, square it. See, we have a 2 in there. Yeah, I skipped the 2. We need 2 minus the mean, square it. And then 10 minus the mean, square it. And 5 minus the mean, square it. We have 5 numbers, so we have to divide by 5. And now let's go take a look at these results here. That'll be a 1 squared, which is 1. This is 0. 2 minus 6 is a negative 4. So square that to get 16. 10 minus 6 is 4. Square that to get 16. And 5 minus 6 is a negative 1. Square that to get 1. Now we need all of the results here. So 1, 0 is 1. And then 16 will make 17. 33. And then 34. So we need the square root of 34 over 5. Rounded to the tenths place is going to be 2.6. Now don't forget what we're doing here. We have the standard deviation of 2.6. We found a mean of 6. And this is the item we're going to compare, which is 5. From the last list, we had an item of 5 that we're going to compare, a mean of 5, and a standard deviation of 2.5. Now that's the bulk of the work. All you have to do is come up with something that's called the following. You're looking for a z-score for both numbers. Remember, from list 1, we're going to use 5. That's an item from the list we're using. And from list 2, it had a 5 in it, so that's why I chose it too. We're comparing those two numbers. And what you have to do is use the formula for finding a z-score. The formula for finding a z-score is the item minus the mean divided by the standard deviation. And I'll label those out. This is the item, which would be a 5, like we chose from list 1 and list 2. X bar is a mean, and this notation here is standard deviation. So you need the item, the mean, and the standard deviation from each of those lists that we have. From list 1, remember that the item, and I'll write this as list 1, the item was 5. So we put in 5, and the mean from list 1 was also 5, and the standard deviation was 2.5. So if I do this formula, 5 minus 5 on top, that's 0. Divide by 2.5, the answer comes out to be 0. Hold that number. Z is 0 for the list 1 item. Hold that, and we'll go do the same thing for the other one coming up next. Don't forget the z-score formula is the item minus the mean and divide by the standard deviation. So this is for list 2. Z is 5 minus 6 over 2.6. Remember, this is the item, this is the mean, and this is the standard deviation down there. So you come up with a negative 1 over 2.6. Divide that and get a negative 0. And we'll take it to 2 places, 0.38. Negative 0.38. Now from the first one you had 0. From the second one you have a negative 0.38. So go look at this. From list 1 you had 0, and from list 2 you have a negative 0.38. Don't forget your curve, and I think I can put a picture in real quick. On your curve, this is 0, 1, 2, and 3. This is negative 1, negative 2, negative 3. Now plot those points that we have. From list 1, here's where 0 is at. We'll make that one green. And from list 2, it's a negative 0.38. So it's between 0 and negative 1, approximately there. Now to answer the question of which item had the better performance, was it the 5 from list 1 or the 5 from list 2? The answer is found by simply comparing these two numbers. Which one is larger? 0. So your answer to the entire problem is list 1, item 5, had the better performance. On this example problem, we'll work this one together, and we'll write the lists side by side this time. List 1 and list 2. List 1 is going to be 621192. And list 2 is going to be 10, 12, 16, 19, and 3. So what you got to find for each list is going to be the mean and the standard deviation. And I'll tell you ahead of time that the question you have to answer is, which had the better performance, 11 or 12? You can't just look at it and say 12 is higher, so that's the answer. You have to go through and do the formulas, because it could be that 11 had the better performance. Because think of it like a basketball game. If you're scoring 50 points a game, but you're playing teams that are ridiculous, they're just not very good. But then somebody else is scoring 50 points a game, and they're playing teams that are like in first place in their league. There's a difference between the two. One had an easier time, the other one had a more difficult time. So this evens everything out with these formulas. All right, so let's go through and find the mean of both lists at the same time. So we'll have 6, 8, 19, 28, and 30. So 30 divided by 5 would be 6. The mean is 6 for the first list. For the second list, we have 16, 26, 38, 57, and 60. 60 divided by 5 is 12. Mean of 6 and 12 for list 1 and list 2. Now we have to go back and find the standard deviation for list 1. And I'll try to do this within two sides here. We'll put list 1 on this side. You'll have 6 minus 6, and then 2 minus 6, 11 minus 6, and then 9 minus 6, and 2 minus 6. All of that divided by 5, and you need the square root. Okay, if we simplify that out, we'll have 0. There's a negative 4 squared, which is 16. 5 squared is 25. 3 squared is 9. Negative 4 squared is 16. So 16 and 25 is 41, plus 9 is 50. 16 is 66. We need the square root of 66 over 5. Square root of 66 over 5 is 3.6. Standard deviation of 3.6 for list 1. Standard deviation for list 2, we're going to have 16 minus 12, square it. 10 minus 12, square it. 12 minus 12, square that. 19 minus 12, square it. And 3 minus 12, square that. And that has 5 numbers in the list, and the square root. So if we go back and simplify this, we'll have 4. 4 squared is 16. Negative 2 squared is 4. 0 squared is 0. 7 squared is 49. And negative 9 squared is 81. Add them up to get 16, 20, 69. 69 and 81 should be 150. So we need the square root of 150 over 5. Square root of 150 over 5 is 5.5. Next up is finding the z-score, and for list 1, that would be the item 11 minus the mean 6 divided by the standard deviation 3.6. And we'll go ahead and write the formula for list 2. That would be 12 minus the mean, which is 12, and then over 3.6. Oh, 5.5? I don't know. I wrote 3.6 twice. Yeah, so 5.5. And either way, on the second one, since you have 12 minus 12, it's 0. So that one comes out to be 0. But over here, we have 11 minus 6, which is 5. And divide by 3.6. 5 divided by 3.6, 2 decimal places, 1.39. So which one had the better performance? Which has the greater number? List 1. And it was item 11. I color-coded this assignment so they don't all run together. So 1 is blue, 2 is red, 3 green, and 4 purple. And your questions are out to the right. So when it says, like in number 1, compare 7 and 11, that 7 is from list 1 and 11 is from list 2. First number is list 1, second one list 2. And that means we need to change this down here for number 3. It should be 6 first and then 5. And number 2 is okay, number 1 is okay, and number 4 would have to be written in reverse. It should be 17 and then 13.